Hello, Algebra 2. Today we are going to do one of my favorite things with trig. Actually, I think I probably say that about every piece of trig because it just gets more and more exciting. We are going to take and apply what we know about sinusoidal curves. I just love that word, sinusoidal, which really just means an equation in sine or cosine, something that creates that wave. And we're going to see how some real world situations can be modeled by a sine or a cosine curve. So one of the best ways to do that is to think about a Ferris wheel. Now, the Ferris wheel is not my favorite ride because Mr. Mac likes to rock those carts, and there are no seat belts or harnesses, or I don't even know what the proper term is at them. And I always wonder, when the last time those things were oiled, and will it really stay together? And I fear that I will fall out of my little cart. But occasionally I do get on a Ferris wheel. But hopefully you've experienced that as well. So you know that when you get on a Ferris wheel, the ride doesn't automatically start. There is this loading and unloading process that you have to go through on the ends of that ride. And so unless you are the last person on the Ferris wheel, your ride doesn't actually start with you at the bottom of the Ferris wheel. And so that's a piece that we really have to remember as we begin to model this Ferris wheel ride. So let's read here this situation, and we want to be thinking about key pieces of information as we read it. Things like, is that a maximum? Is that a minimum? Did they somehow tell me what the period length of this wave will be without just directly saying the period is 10 or whatever it happens to be? So you want to be on the lookout for those pieces of information. So here we go. As you ride the Ferris wheel, your distance from the ground varies sinusoidally with time. Now, that whole phrase, varies sinusoidally with time, just means you're going to use a sine or cosine equation. When the last seat is filled and the Ferris wheel starts. Now, notice it did not say that you were in the last seat. Just when the last seat is filled, you are over here somewhere to the right here. You have been on the Ferris wheel. So you are not the last person. We do not know what our height above the ground is when that starts. Let t be the number of seconds that have elapsed since the Ferris wheel started. So t is going to be our independent variable. You find that it takes you 3 seconds to reach the top, which is 43 feet above the ground. Ooh, that sounds like a maximum, doesn't it? The top, 43 feet. So they told us the maximum. And that the wheel makes a revolution every 8 seconds. Oh, a revolution. You go entirely around. That's telling us the period right there. And the diameter of the wheel is 40. So from here all the way to the top, that's a distance of 40. So that's going to be something with that stretch, that amplitude. Now, the amplitude's not 40. We're going to have to figure out what that is. So what we're going to do is we're going to begin to sketch out the information that it's told us. It's a sketchograph of the sinusoid. Now, you might be saying there is not enough information in that problem. And it seems like there's not. But we're going to take all of our knowledge about sine and cosine curves and put it together with the information that they gave us, and we will be able to come up with a graph. So I am going to create a set of axes here. And I'm really only going to worry about quadrant 1. Why? Because t, my independent variable, which is time, it's going to go on the x-axis. I'm not going backwards in time. So time will always be positive. And the dependent variable is distance, your distance varies with time. So time is your independent, distance is your dependent. That Ferris wheel is not going beneath the ground. And so I'm going to put distance above ground. Or you could have put the height. Sort of the same thing. Okay? So I label my axes. Now let's see what it says. It says it takes me 3 seconds to reach the top. So I think I'll go 1, 2, 3 seconds. And I'm going to be at the top. I'm going to be at a maximum. That maximum is 43 feet. So maybe I want to do 10, 20, 30, 40. They sort of got a little bit closer together all. This is why it's good to work in pencil. 40 and 50 right there. I'm not going to make it to 50, but it will help me figure out where 43 is. Now, it's not essential that we have every tick mark there. Let's see if that's 45. This would be right here about 43. I'm going to label that maximum. So at 3 seconds, I'm up at a maximum of 43. Do you see how I'm just reading through and pulling the information it told me? And it says that the wheel makes a revolution once every 8 seconds. So if I'm up at the top at 3 seconds, 8 seconds later, not at 8 seconds, but 8 seconds after 3, which would be 11, I'm going to be back up at the top. So 3, 4, 5, 6, 7, 8, 9, 10, 11. I am going to be back up here at 43 feet. All right? Now, that means that the period length is 8 seconds. There's 8 seconds in between. So that's really about all the information it tells me, except for how the diameter of the wheel. But remember what you know about waves. These are 2 consecutive maximums. What happens halfway in between 2 maximums? Well, that's going to be the minimum. And so halfway in between here, and I can do 11 minus 3 and divide that by 2. Well, that would be 8 divided by 2, right? So 4 seconds later, 1, 2, 3, 4, that's going to put me at 7 seconds. At 7 seconds, I will be at a minimum. If you can't think about the 7, just walk your fingers in the same amount from either side, and there's going to be where the minimum is. Now, what is the minimum? How far above? Is it just at 0 because we're on the ground? No. Because if it were on the ground, it wouldn't be a very comfortable Ferris wheel ride. You would hit the ground every time you went around. But the wheel is 40 feet in diameter. And we know that the maximum height up here is 43. So that must mean that the minimum down here is 3. We are 3 feet above the ground. So somewhere like right there at 3. At 7 seconds, I'm 3 feet above the ground. Now what happens halfway in between a maximum and a minimum? Well, that's where that 0 value will be. That will occur at 5 seconds. And then there'll be another 0 here between 7 and 11 at 9 seconds. But where will that 0 or that halfway point be? Well, remember, it's going to be halfway between the maximum and the minimum. So here's 43. Here's 3. That's a distance of 40. That's a diameter. So I need to go halfway. That would be 20. 20 less than 43 and 20 more than 3. That puts us at 23. I'm going to put a dotted line at 23. Right there. And so at 5 seconds, I have a height of 23. At 9 seconds, I have a height of 23. And I could keep graphing this function. Notice every quarter point occurs every 2 seconds. And that's because 8 divided by 4 is 2. So every 2 seconds, there's a quarter point. So at 13 seconds, I would be back at a 0. I can also take it back 2 seconds. At 1 second, I'm at a height of 23. Do I know what the height is at 0? No, because it must be somewhere in between here, because if I were to actually go backwards in time, if you could, it doesn't make logical sense, but that -1 would be that minimum. So here is our graph. Seemed like we didn't have enough information, but we actually did. And it's sort of like a point right there. Okay. But the domain, I'm not really going to include behind there in the negatives because that wasn't actually part of our Ferris wheel trip. So there we go. A beautiful sketch. Now we're going to apply our thinking about how can we write an equation for this. Well, actually, let's do part B first. I'll move that up. Part B says, what is the lowest you go as the Ferris wheel turns, and why is this number greater than 0? We already know this. The lowest we go is 3 feet. And this is greater than 0. I'm not going to write all this out. Maybe I will. Greater than 0. Because you don't want to hit the ground on the Ferris wheel ride. That would not be a very smooth ride. A little bumpy. All right, so we know that piece. Now we want to write the particular equation of this sinusoid. So it can be a sine equation. It can be a cosine equation. Depends on what you want to do. So I think I'm going to do a cosine just because I know this point, this was the point that we started with. It was a maximum. And so that makes me want to write a cosine equation. But you can write a sine if you want. So y equals, let's see. What is that stretch between the midline and the maximum? Well, that was 20 because it was half the diameter of the wheel. So 20 cosine. Now I need to find that b value. Remember how b is equal to 2 pi divided by the period length? What did we decide the period length was? That was 8. So 2 pi divided by 8 is pi over 4. So cosine of pi over 4. And then I need to think about what is my horizontal shift. How much do I need to shift so that I can start at a maximum? Because the maximum is not on that y-axis. Well, I had to shift over 3. T minus 3. I'm using t for time because that's what it told me to do. So t minus 3, shift to the right 3, and then I need to add that vertical shift. That's where the midline is. Where were all those midline points? They were at 23. All right. So there's my equation, a rather fancy looking equation. How can I be sure it actually is correct? Well, grab your calculator. And I want to take a look at how to graph this because when we go to do some predictions, I'm going to let my calculator do it. So first thing to make sure of, and that is your mode. We are graphing everything in radian mode. Make sure that you have radians. If you have degrees, nothing is going to look correct. So make sure you're in radian mode. Go ahead and hit y equals, and I'm just going to put this in. 20 cosine. Now, pi over 4, I'm going to put that in another set of parentheses. Pi divided by 4. Notice it's still in the cosine. And then another set of parentheses, The t really is the independent variable. So x minus 3, close the x minus 3, then one more to close the cosine. Okay. And then plus 23. Now, if I just hit graph, I think I'm in a standard window here. I don't see a great picture of this graph. And so I want to change the window. I like to actually use the scaling that I have over here to change the window. So if I go to window, I started my time at 0. And I went out to 13. Maybe I'll go out to 20. And I'm going to go by ones. Now the y minimum, I'm going to do 0 up to 50. I'm just following because I want my picture to look like the graph I've drawn. And I'm going to go by tens. So even the scaling looks the same. And I'm hoping that the graph on the calculator looks the same as the one that I drew by hand. And it is looking pretty good. Look at that. My graph on the calculator went out to 20, so it's a little bit further, 13, somewhere around here. Now, if you press trace, I like to check a couple points. I like to check the information I have from the actual problem. So I hit trace, and then at 3 seconds, so I'm just going to hit 3, I want to hit enter. I know that I should be up at a maximum at 3. Oh, look at there. At 3, I'm at 43. Let's just test 7. Are we at a minimum? Okay, we are. And then back at 11, a maximum. Great. And let's just test one of those midline points and see if we're actually at a height of 23. If I did it correctly, let's see, at 5 seconds. Do you see how I'm just sort of testing that piece out? Now, when I'm in the trace, this is beautifully helpful because predict your height above the ground when t is 6. Just put a 6 in. Let the calculator do it. Hey, 8.86. That is much nicer. 4 1/3. You can either do 4.33333333333 and do enough threes that tricks the calculator into giving you the exact value, which happens to be 33 feet. Or you can put in 4 plus 1 divided by 3. There is 4 1/3. And we still get 33. All right. T equals 9. Put in a 9 there. Ooh, and we get a height of 23. And 0. Put in 0. 8.86. Hey, that actually is of interest because at time 0, that tells us our height off the ground when we started the ride. We were not the last cart to be filled. We were probably the second to the last cart to be filled before that ride started. What happens if you don't like this trace piece? How could you figure these out? You can go back to your home screen and you can just let's plug 6 into this equation. You would go 20 cosine pi divided by 4 times that t is going to be 6. Close that parenthesis plus 23. And you get 8.86 as well. It just happens to be a lot of work. So, I want us to not be intimidated by these word problems. I want you, in your homework, you're going to take another Ferris wheel ride. On Wednesday, we're going to extend it to some other situations, not just a Ferris wheel, but want to give you some practice with something familiar for your homework today. So sketch that graph, pull the information off, write an equation, test it out on your calculator, and see what you can do. Let me know if you have any questions.